Before we continue writing code, let's talk a little bit about testing philosophy. This is actually a contentious issue, and you'll probably have to do a lot of soul searching, experimentation, and so forth before you decide where you live on this spectrum. So naturally, one way that you guys always do testing is you run your entire program and you see if it works. That's a so-called system test or integration test. You're running it, seeing if it works. Okay. One alternate approach, or even not necessarily an alternate approach, but a complementary approach is don't just run tests for the whole thing. Write tests for every single unit of your program. So if I have a bunch of pieces like sort and print and other things that constitute a larger class, instead of just testing, say, the main function or some high-level function, I can instead test all the little pieces. Okay. So JUnit, that library we've been sort of alluding to here in our previous example, makes it really easy to do that, right? It makes it take maybe 4 lines what would otherwise take 30 or 40, right? So unit testing, what's good and what's bad about it? Like why is it a good idea? Okay. Well, one reason is it allows us to get confidence in our basic modules. So just as when you build an airplane, right, you don't just assemble it and start flying it and hope everybody doesn't explode midair and die terribly. Instead, you make sure the wheels stay on, that the wheels stay on, the wings stay on, that the aerodynamic flow is appropriate. That's how airplanes are designed and built, right? So you want to understand that your little pieces work. So say you do a system level test. I just run main, right? I run this program. Instead of getting agregadas, conchis, I get just insane garbage, right? At that point, I don't know if the problem is sort, if it's print, if it's main, if it's something else. But by testing each module, it lets me narrow down the scope of things I need to think about, right? So one of the biggest barriers to writing big programs is just knowing where to look for things like bugs or knowing how to remember the whole state of the thing. In programming, you always want to be just as lazy as possible. Okay. Another reason is that you can decrease debugging time. So suppose I have a bunch of unit tests and I accidentally introduce a bug, right? And then I run the top level test and everything's broken. Now maybe I have a test built specifically for sort that just catches it and it throws me right to where the bug is. And it's amazing. And it's glorious when this happens. And another is, well, actually, if you remember, if you took 61A, there was the interesting autograder where you would have to prove that you knew how things worked by submitting a little answer. It would say basically, what should this function do with this input? And if you could give an answer, well, then that meant that you understood the problem. Just so with our sorting technique, right? So in order to write this test, if we look at what we had here, that's the recording, Linux. We look at our test here. We had to understand what sort did in order to write this expected. So just the mere act of writing a test can help clarify what that unit is supposed to do. And why not? Why shouldn't we unit test everything? Well, of course, building tests take time. And tests can, of course, have bugs in them. They're code just like any other. And so while JUnit makes it easier to avoid bugs by making the call short, bugs can still creep in. And maybe what you're building a test for is just a little silly. Like, it's just not worth your time. And that's the biggest trade-off that you'll have. And then later, whenever you build bigger systems someday, you'll see that mid-level units, so if we have a whole hierarchy of all kinds of stuff happening from the top level and somewhere in the middle, maybe it's like getting data from a webcam and a microphone and who knows what, building a test of those middle-level units can be tricky. And we're not going to talk much about that now, but you can maybe imagine why it might be hard to test something that relies on lower level and higher level, that's supposed to live within, it depends on both lower level and higher level pieces. And then lastly, if you get too used to unit testing, you may decide because every unit works that the whole system as a whole should behave well, so that may trick you into not actually testing the whole system. Okay. All right. Related idea. So that's the idea of unit testing. Now here is the idea of testing first. Okay. It's a slightly different idea. It's closely related. It's not an alternative to unit testing. It's I guess a supplement to the idea. Again, complementary. Okay. So in this approach, which is sometimes called test-driven development, the idea is that before you even write code, you write unit tests. And that's what we've done so far in this lecture, right? Before we ever wrote sort, we wrote a unit test for sort, right? And why is this good? Well, again, one reason is it helps clarify the task. So it's good to clarify the task before you ever write anything. Another is it's good testing discipline. There's something that some people find addictive about this, that you write the test and now you have a challenge that you can try and succeed at. And it helps you get better testing discipline. It helps you get motivated. Some people just find it plain fun, but it also makes sure that hopefully you're building code that other people can trust. Okay, And why not? Well, it can be a waste of time. Maybe you're setting up too much of a little game for yourself. Or maybe the tests you're writing are so silly that they're never, ever, ever going to fail. Okay? So there's some trade-offs there. And this week's readings, or this lecture's readings, go through some of the trade-offs that people have thought about in that regard. Okay? But by the end of this class, you're not going to be experts at this. This will just, now you will know the basics. Okay? So let's talk a little bit more about what test-driven development, the flavor that it's taken on, the people who are proponents of this, think about building programs this way. Okay? So this should be probably rather unlike anything you've done before. Okay? Or I'm assuming you haven't done this before. So what does it mean to build a program using the test-driven development style? Okay, well, often what happens is you have a program and you want to do something new. So in our case, it was sorting, right? We've decided that that's something we want our program to be able to do. So then we write a test for that feature, and then we run the test, and it should fail. And we did that, right? We went in here and we ran the test, and we saw that it failed. And it failed naturally because of the fact that we haven't implemented the thing yet. And that's great, right? Because that means our test is at least doing something. Because if it was already passing, then it's a useless test. And so now we've entered what some people call the fail cycle, or the fail step in the cycle, or the red step. Okay? Then we write code that passes the test, and we'll be doing that in a little while with sort. And that's nice because now we know that our code works, or at least according to the test we set up. And at that point we can say, good, everything's great. It's certifiably good, at least by the certification we've written. Now at this point, if you decide, okay, well the sort method I wrote, while it works, is kind of slow or it's kind of ugly or whatever, so I'm going to change my code up a little. I'm going to delete these pluses or whatever that I have here. I think if I change these indices, whatever, it should still work. And because I built the test, I can actually test my changes, my thing to make it faster or cleaner or more beautiful, and then can cycle back through. So if I hit red, then I can get back to green. Okay. So this is not required in 61B. You may decide you don't like this at all. Maybe the only time you'll ever do it is in Lab 3B or watching this lecture, but it is definitely the case that testing is a good idea. And when you go to job interviews, having tested and being able to think about testing will certainly be a good thing. Okay? And if you're just working on your own personal projects, that's great. And so I'll show you right here that I've been talking about this, people getting addicted to tests. So this is an example. There are various GUIs out there that will show you the results of your tests. IntelliJ does this to some degree, and the idea is when you run your test, you get this green box, and you're very excited, and you say, great, all right, it's working. But whenever you have an error, it's red, and that motivates you. Okay? So that's TDD. And again, love it, hate it, well, at least be aware of it. Okay. Now this is the exact opposite. This approach here, test-driven development, is the exact opposite of the so-called naive workflow. This is often what novice programmers do, or I do when I'm sleepy or whatever, or like really need to get something done. So novice programmers sometimes do this. They read the spec, whatever they're supposed to do, then they write an entire program, maybe like 200 lines of code, who knows. Then they compile and there's like 40 of compilation errors and they go and fix all those. And then they basically just get rid of all the bugs by running the top level method. You just run main, and wherever it crashes, you add a bunch of print statements and you create all this cruft. Sometimes even basically you're just adding print statements. Like it wasn't here, okay, here, 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 and so forth. Or you can, and this silly method, what ends up happening a lot of times is if you're, say, debugging a sorting method in Python, you might end up with something like this. I don't know if you've ever written code that does this, where you have all this, like, got to the spot, and like here, printing out things. This is just a big mess, okay? So I'm going to say that this workflow right here, it is slow and is unsafe. Like running through this way, it's just not a good way to conduct yourself. Now, I'm not saying that print statements are bad, by the way. They're not inherently evil. Print statements can actually be a really good debugging tool, but you want to use them judiciously. And writing tests really helps you narrow the focus of what you need to be digging around inside of. Okay. Now, one other really nice thing about the unit tests, what they do for you, is I often think of whenever I'm debugging like this, like I'm building scaffolding, and I know that there's some sort of problem in my cathedral or whatever. So I build all this scaffolding and I have all these inspectors and they're carefully looking through all the stonework and saying, okay, you know what? Yeah, I finally found it. This is the problem. And then all I end up doing is like rotating a brick or like flipping a minus sign to a plus sign or something that I didn't know about. And then I have to disassemble all this scaffolding, okay? Well, it's a darn shame because I did a lot of insight. Like I gained a lot of insight with all the scaffolding. I noticed little things I'd never noticed before in my program. There's all this interesting instrumentation. but now it's gone because I want to remove it because I don't want these print statements in my code anymore because they're not supposed to be there. Just like in a chapel, you don't want to leave a bunch of metal everywhere unless it's like a chapel to the metal god or something. That's fine. So what unit tests do for you is they basically act as sort of like monitoring robots that are always there, right? So that you, throughout your cathedral, you leave all these little secret creepy robots recording everything around them, so that if anything ever goes wrong in the future, if that stone gets turned again somehow, it yells at you and says, no, something is broken. Okay? So unit testing is just a better idea than having a bunch of scaffolding like this, having to rebuild it every time you debug. Okay? So test-driven development, this idea of writing tests first and then going through this somewhat formal process, that's probably quite different than the naive workflow that you might have done in the past. And what you like, whatever you settle on as a programmer eventually is somewhere in the middle. But I encourage you to experiment with this for maybe project, well, you'll have to, well, actually you can't in project 1B because I didn't tell you about tests before 1A. But I encourage you to experiment this with future homeworks and see what you like, right? So that's philosophy.